Hopefully everyone's here in the right talk. First of all, I just want to bring up the sponsor slide. Without the sponsors, of course, we wouldn't be able to be here today, so do take a look at the booths. Okay, so some of you may have seen this study or statistic from MIT research that 95% of Gen AI pilot projects fail. And yeah, there's a myriad of reasons for that. It's a worthwhile study to have a read if you're interested in. However, what I'm here today is essentially to help you avoid becoming one of that 95% statistic. So, a lot of you here, we're speaking predominantly to a crowd who are familiar with software development. And I'm going to frame this in the context of what you may do in terms of from a software development perspective. So hopefully there'll be some useful analogies here for people along the way. And so from a basic web app, this is what we're looking at. We've got untrusted structured input coming in. So I'm going to differentiate here between structured and unstructured input here. And so when I'm talking about structure, we're talking about something like a JSON payload or XML or whatever you're kind of dealing with. We've got some sort of client and server-side validation. We've got this concept of deterministic processing. The idea is if we've written our code well, we've got it tested well and dealing with race conditions and whatever else and appropriate fallbacks, for the most part, our code should be deterministic. We produce a deterministic structured response. We've got some sort of observability sitting at the bottom there. Now, a lot of software developers will be faced with a case where they're going to have to start developing some sort of naive large language model based web app. And so for the context of this one, just to be clear, when I'm talking about AI, I'm talking about the more popular AI at the moment, which happens to be in the form of large language models. So I won't be going into some of the other variants in this particular talk. And in the case of large language models, we're dealing with a slightly different structure here. And the most important thing to notice is, once again, we've got some overlap. We've got untrusted input. But the difference is we're dealing with natural language input typically. And this is what we refer to as unstructured type data. We've got some sort of client and server-side validation, just like we would have in a classic app. But there's probably something else that we need to do here. And then this is kind of like the big black box that we've got sitting here, or in this case, the pink one. We've got some sort of non-deterministic processing, as it were. And then finally, what we're producing here is typically kind of two types of outputs. We've got both the kind of classic structured output, or we've got this kind of unstructured output. So whatever the large language model has essentially produced. And then, once again, we've got the observability. So the thing is yeah, how do we fill in those gaps? How do we deal with this kind of non-determinism when we're developing these types of apps? And so one of the things is you might be familiar with when a particular request comes in, just like in your standard deterministic code, there'll be often a particular type of answer that you want to be given to particular types of questions. And so what I mean by this is probably a good analogy to look at is when you're visiting a website, for example, often there's this kind of concept of frequently asked questions. So a large group or cohort of your users will have a certain type of question which they'll be asking over and over again. And rather than routing that through your large language model to essentially produce the same output every time, you'd ideally want to go ahead and route this somewhere or another. And so this is where we get in the concept of routing, or in this case, yeah, not every natural language interaction requires a large language model in the loop. And this is probably a big part that people miss. And so with this, we've kind of got this idea that we've got this, yes, something in the middle here. We've got unstructured, once again, we've got that same kind of flow, but we've got this kind of thing where it somehow needs to understand the natural language that is going into the system and then route that accordingly. So we've got the case where we put down a deterministic route. We're saying, well, listen, we know a lot of our users are going to be asking this question. So the thing is, we identify from their natural language query, we need to somehow route that up to the appropriate deterministic processor, so where it's going to be producing a fixed response, or otherwise that we've identified doesn't fall into this particular category and we put it to our large language model as before. And so this is where the concept of semantic routing comes in, and this comes up in a myriad of forms, but the principle is essentially fairly easy here. So you've got this kind of fast decision-making layer which goes ahead, looks at what's going through, and the way that you actually achieve this idea that it's able to match against natural language input is using the kind of concept of our embeddings, which will identify basically what the person's putting through, because you've got a good idea that there's a certain number of ways you can ask a particular question, and by putting in the embeddings in the model, you can do a similarity against what the user's put into the system, and then route it down your deterministic path. And then once again, if it doesn't follow this particular route, you can look at following the other way, in which case, yeah, we go to the large language model again. So just as outlined before, the idea is you create multiple embeddings for the queries that you want to capture. And there's a little bit of nuance here in terms of whether you're using a standard embedding model or something else where we've got some more kind of nuance to those. But the idea is you capture that kind of series of questions. You compare the request against the embedding, and then basically if it meets your similarity score, so saying, okay, there's 90% similarity between what the user's asked and this particular embedding, then we can go ahead and route it accordingly to perhaps our fixed response. There's a further variant of this as well. So once again, we're trying to avoid the large language model in this particular case. And given this is a talk on AI and large language models, you may be wondering why I'm doing this. We're trying to remove that kind of non-deterministic option from here. And so we've kind of got a similar ability here. So you've got the thing where you've got a kind of almost like a static response, but you've also got the ability to kind of do this concept of dynamic routing as well. So once again, you've kind of got your initial embeddings going through, and it's identified that's one of those, but it's actually a query which requires a dynamic response. This is where you can go ahead as a result. Since it's matched your particular embedding, you can say, okay, I know that they're querying about this particular entity in my database or this particular item of interest. I've got a particular query which fits this, and all I really need to do is extract the parameters in terms of what the natural language that they put forth to me. And so in that case, you'd have once you've identified the route, you've got your 90% similarity to what you're looking for, then you can go ahead and feed it to a specialized model which goes ahead and its simple job is to go ahead and extract the parameters and then pass that to your API call as opposed to doing something like MCP or whatever in that particular case. So semantic routing is one way to avoid that, to reduce that non-determinism. And as you can imagine, as a result, your system gets slightly more deterministic and more reliable. So yeah, that's one way, and that cuts off a lot of perhaps traffic that you'd otherwise feed through your large language model, which has got cost implications as well as timing implications as well as uncertainty implications there. But there's still going to be things that go through. So I've explained how we go through this kind of deterministic route, but we're still going to the large language model at this stage. And so we need some sort of validation on top of this. And so how do we do this? And this was the kind of the question mark that I put in my earlier slide here. So many of you in the audience, or some of you may not, it's this concept when you hear of guardrails in AI. And essentially the way it works is this. You've pretty much got a number of threats that you want to deal with and the different ways that you can go ahead and handle those. So kind of got the basics which are available in a lot of these large provider models. So if you're using Azure, or if you're using OpenAI, or if you're going ahead and doing something with Anthropic or something of the like, they often provide these kind of guardrails for you for most basic cases. So often it's provided by the particular platform you're using, but you've also got the ability, if you're using an open source model or a platform which doesn't necessarily offer that, you do have a number of options here using a type of guardrail framework. And I won't be going too much into detail in terms of how to deal with this particular one, but needless to say, there are guardrails which have been developed for hate speech, etc., which are probably the best option to go out of the box, but you've also got the option to go ahead and start trawling through this data yourself to be able to classify it and go down that particular route. But for the most part, you'll be going for a third party for this. The second one falls into kind of a similar bucket. So this is where when you're using a platform, it won't necessarily match that because you're not necessarily sure what this is going to look like. And this is when we're talking about prompt injection, jailbreaking, and malicious code generation. So for the most part, the models that most people will be using when they're using something provided by a platform will have this to some degree, but because of the sheer number of variants in terms of what people can come up with here, it's just something they can't provide necessarily out of the box. So they have this to an extent. So they have the things where someone's actually trying to go ahead and access the model, but depending on the environment that the model is embedded in or the particular industry, there's additional steps that you're going to need to take here because the models off the shelf typically are going to be trying to cater essentially for everyone. And in this case, there's going to be a number of things that you want here. So for once again, for prompt injection in most cases, there are a number of guardrails that you can go ahead get from third parties to kind of deal with this. And I'd just like to point out here, and just like security in general when it comes to software development as well, this is something which is of far greater scale in terms of what most people will be able to do themselves when they're looking at trying to secure their application in this regard. And so this thing as well pretty much gets delegated to a third party because prompts are currently, it is quite sophisticated, this space, in terms of the different attacks that people are trying. It's a classic lock and thief type scenario here. And the thing is whatever system that you come up with or however intelligent that you think you are when putting something together like this, it'll be out of date within a week or a very short kind of time period for this once again. So there's all sorts of things for covering the basics. So in terms of whether it's rotating the characters in a string or embedding something in a prompt. But there's also things of progressive attacks as well, where the first prompt that the user puts forward might seem a little bit innocuous, and then it kind of progresses from there until they kind of break the system. So In short, for this kind of thing, once again, for prompt injection, initial pass will be going for a third party. And if you're really invested in this, you need to understand that it's a significant time investment here. So once again, this comes in effect for your input guardrails. The third one here is a lot easier to deal with. So once again, most of the models that people are using aren't going to have this in mind when they're being developed, because they're attempting to cater for everyone. We've got this concept of PI and confidential information. Depends on what industry that you're working on in terms of what your requirements are here. But essentially in this kind of case here, there are, once again, packages that you would use for standard personal identifying information removal, such as something like Presidio. And there's a number of options that you've got there. And in cases when you're trying to feed people's data through the large language models, perhaps you want to go ahead and use something like start changing their name so you can't actually track who that particular person was. So you've pretty much got multiple options here. So could involve masking private data, masking phone numbers, masking names, masking credit cards, or anything that people are kind of putting into your system. You need to think about this up front. But once again, you may think that putting in hashes into the large language model may end up with some kind of funny results, and so that would where you'll be start using a tool like Faker, where you go ahead and start replacing names or whatever else there, so that you've got that certain level of anonymization available to you. And yeah, finally, you've got this other option here where you've got off-topic queries as well, and there's a couple of things that you've got here if you really want to kind of go down that route. So I guess the point that I'm trying to make here is you're never going to be able to cover all variants with your whatever you come up with for your system prompts, and instead you need to start thinking about a different type of input validation on top of the kind of basic thing that you might have had for a classic web application, which is particular things in terms of manipulating the form or the payload in that regard. This is a lot more, lot trickier, a lot more involved. There's a lot of third-party options that you can go with this, but there's also some packages, as I say, for whether it's of a PI or user intent or whatever else. And when I mention this part here about using a separate model, I'm not necessarily talking about using another large language model. There are some models which are developed from several years ago that you can actually do this from the natural language processing space to go ahead and extract the user intent, which is very much a thing from around 2017 and onwards. And then finally, we've got one which is a different kind of guardrail again. So with web applications, you're often looking to serve people at scale, but the thing is the cadence or the rate that the large language model typically processes user responses is going to be completely different to what you're looking at from a large language from a classic web application. So whereas an application might be looking at 40,000 requests per second or whatever else it is, chances are the large language model underneath it requires a lot more compute time to go ahead and come back with the responses. There's a lot of delay associated with this, and there's also kind of active attacks people do with this. So when you're kind of dealing with this situation as well, we've got a large language model-based app, you're going to want to be thinking about having some sort of rate-limiting middleware or slow API or equivalent to go ahead and manage the number of requests that you're getting there. So we've got some guardrails around the input. So we've got our semantic router, which is putting giving us answers to commonly asked user questions. We've also got another level of kind of input guardrails in terms of, okay, trying to reduce what's coming in, but the thing is we're never going to get a perfect result. So each one of these is getting it slightly higher towards the reliable output, but the thing is given you're dealing with an undeterministic model, it might produce output that you're not interested in, or someone's come up with a particularly crafty prompt in terms of being able to exfiltrate data, as it were. And so we've got a kind of number of types of things here, and this is one that people often miss. So I touched on this briefly when I was talking about prompt injection, just how sophisticated it is, especially if you're using internet source content as well. People are intentionally poisoning data, whether it's in the music industry or from the creative industries with images, etc. But it's also happening with text as well. And then there's going to be a series of attempts that you're not necessarily going to be able to recognize, and ways of exfiltrating data that you may not be familiar with. And they can be things such as going ahead and asking the model to go ahead and produce an image tag, for example. And the image tag contains an exfiltration of your data, and the image tag is going to go ahead and hit whatever the URL is at the front of the image tag with whatever payload is attached to the end of it. So you need to think about, does my large language model-based application need to generate HTML? If not, then you need to go ahead and consider it and have some sort of thing to be able to detect tags on your output or whatever else. Because once again, these large language models are capable of producing lots of different types of outputs or whatever, but you really need to kind of focus on some of these things. It's like, okay, does it really need to do this? Does it really need to do that? And put in appropriate checks for that. Similarly, you've got this a big topic, and it's never necessarily going to be completely solved with the current generation of models that we're dealing with. but you want to look to mitigate, of course, hallucination and also determine that the response that it's come up with has some provenance and has got some kind of basis in the data that you're working with. And so there's a number of techniques to do this as well. Classic, using a second model, which basically goes ahead and compares the input and the output provided and determines how similar is the output that the second model produces to the first model. And if they're significantly different, then chances are you've got a hallucination going on there. There's a new advanced technique, which has just come out relatively recently, and just in the last couple of weeks has been published, or maybe the last 2 weeks. Bayes, which is another approach where if you're using a model from OpenAI, as it were, you've got the ability to see the probabilities of the various tokens which it's gone ahead and produced. And by going ahead and masking separate bits of the text that you're feeding into the model and getting a measurement of the type of response that it's coming back with, if those responses are varying, so this is typically maybe a handful of variants where you're masking different words within the text, and if they're coming back with significant variance, then you've got a hallucination there. I won't go too much into the detail for the rest of it, but there are a number of means to go ahead and attempt to mitigate this. But probably the biggest implication here is they do actually have a cost in terms of time, in terms of how long it takes to get your response, as well as a cost in terms of money if you're putting it through through the same LLM another 5 times and doing your masking of your text there as well. So there's always a bit of a trade-off with some of these. Moving on, some of the other things that you might want to deal with is business logic violations. And so we've got things where mentioning competitors as well. So you might be working in one particular industry, but a competitor is mentioned is covered in the training data, where there's a very high probability of that, given the source that where these models come from. You can do a number of things around this. And so once again, probably the very easy one is to go ahead and make sure that you've got a list of your competitors that you don't want it to go ahead and mention as a kind of your starting point. But this can also advance as well, because people can ask questions as, would you recommend this how does your company compare to this other company, for example, if you've got an open chat bot or whatever else. So these are the types of things that you need to start thinking about, like whether you're masking on the input, but also masking on the output as well, because there are ways that will be able to convince your model to say, well, actually, this company compared to this one, user review said this, this, and this, whereas you've evolved since then, you've got some kind of new product or whatever else that addresses some of those issues, but the training data in the system is going to differ from that and then damage your brand reputation. So pretty much what I've covered here, we've introduced a number of things here. We've got, once again, our unstructured input. We've got our semantic routing to the appropriate system. And the difference is around our large language model in the middle here, we've got input guardrails, which is covering what I just mentioned before, and then this concept of output guardrails. And so I guess the point is it's not necessarily as simple as just plugging your system into a large, commonly available large language model, but you need to think about these different pieces amongst the middle here. And so whereas something like semantic routing is typically very, very quick because it's working with a smaller model and just comparing with your various embeddings that you put into the system, each input guardrail that you put in the system or output guardrail you put into the system has got a cost. And so you really need to kind of work out which ones are the most important to you and how you're going to go ahead and try and address those. So that's a quick whirlwind tour of basically the basic components that you need to start thinking about from putting an app together. And there is 1 or 2 more that I'll be covering at the end there. You'll notice the absence of observability at this stage. So now we've guarded our input going into the system, but how are we actually going to go ahead and try and get the model to create the response we want, such that some of these systems that we put in place aren't necessary? So there's a couple of things to be aware of. One of them, of course, is the needle in the haystack. And this is slightly older results that I've got in here, but it's just as relevant today. The concept behind this is basically, even though the model may offer a large context, like 256,000 tokens, or some of the larger ones, such as Gemini or whatever else, where you're working around with 1 million tokens, just like people, they're not actually looking at all the data in detail and keeping track of it. In fact, they're actually unable to do that for the most part. It's not some sort of way that they've kind of blown out and suddenly understand 1 million compared to, what was it, a couple of years ago where we're talking about 16,000 tokens. There's a lot of optimizations which are done in the model. And just like people, if you're handing them a report or whatever else, often they'll have a look at the executive summary. They might have a glance at 1 or 2 things in the middle and maybe look at what is in the end there. And this is what's referred to as the needle in the haystack. So what I'm trying to show here is basically as the context length varies, on a certain level they start to have catastrophic forgetting of particular facts, even within the existing context window. So as you can imagine, there's a little bit of a theme here. You need to be wary of how much context you're actually putting into there, because knowledge will be lost depending on how early it appears in the conversation there. Similarly, there's also, that has the knock-on effect, as you can imagine. They're actually unable to understand long-going narratives, and a classic example is just say a classic chapter book or something within just say a popular TV series where they've got lots of different characters and lots of different arcs. A lot of these models start to struggle with being able to keep track of who is doing what in what particular area or whatever else. And this is from fiction live bench, where they've gone ahead and tracked some of the models. So you can see GPT-5 here, so it is fairly modern what they're looking at, and some of the open source ones as well. And at what kind of token lengths that they start unable to be able to track certain contexts. So once again, these models might seem wonderful in terms of how they can manipulate language, as it were, but there's definitely some shortcomings here that you need to be aware of. And so basically, the problem is the context isn't as long as you think it is. And this has, once again, you can imagine what that implies. Similarly, when you start putting in tools into the context, because they're not going into something separate, they're also going to the context, they're encoded a particular way. You're going to start confusing the system if you start putting too many tools into it as well. And there's also another kind of interesting thing here that when you start using the thinking models as well, the models start to perform worse the more time they have to think. So once again, you need to be kind of mindful of how you're using these things. So what happens with the large thinking models, as soon as you introduce a flaw, you can imagine the kind of chaining process. It exacerbates whatever flaw, faulty conclusion it came to early on, and all subsequent work that it does on that is going to produce flawed results. And similarly, if you're using the kind of wrong model for your task, then they can often think that if you're using a thinking model for a very simple problem, it might think that, okay, there's a reason they're asking me this. What could it be? And then it starts thinking and starts paying attention to things which are completely irrelevant to the question and start overthinking it as well. So there's a number of things that you need to be mindful of here. And so different techniques that you can use is, if you can start anew, do it. You need to summarize often in terms of what you're doing. So when you're developing these systems, you need to go ahead and put in summaries rather than putting all the historical detail, because the model can get caught up on that. You need to, once again, kind of ties into it, you need to prune irrelevant context or out-of-date context. So this is where you've got something running over time as well, or particularly relevant context, as I mentioned before. And this is one of the techniques that you've seen a lot of agents develop today by the large providers. So I'm talking about Claude Code, for example, developing a to-do list or maintaining a list of your important points. And yes, and then finally, you want to limit the number of tools for a given interaction. So one thing that's very popular right now is MCP and tool use and having this kind of degree of autonomy, but you really need to be selective against for the tools that you're actually going ahead and providing to the system, because there's going to be a stage that's going to be unable to differentiate them, and there's some advanced techniques that you can do towards that in terms of trying to test your system and trying to work out which tool it's going to choose. So once again, just because you can throw the whole kitchen sink of it, you've got a whole array of different MCP servers that you think will be useful, you really need to be kind of directed in your thought in terms of which ones actually apply to the problem that you're trying to solve. Okay, so probably the main point here is, in traditional applications, the CPUs execute structured code in large language model apps. The large language model is the processor, and the prompts are the source code. So it's a bit of a interesting implications here. So the thing is when we're developing software, of course, one of the things that we do with source code is we want to check it in. But when we're working on system prompts, etc., you can imagine the implication that we've got here. And so essentially, coming from a software development background, most of you here, I'd assume, just like source code, your system prompts and the prompts that you're using within your agents or whatever systems that you're putting together will need to be version controlled, because they'll iterate over time. The way people use your system will change over time as well. And so you want to track that. You don't want it to just go in your regular Git repository or whatever else, but you need some way to be able to track it and track your model's performance across the various prompts that you worked with. So as a result, you need to, of course, test your prompts and then test different versions of your prompts against what the user is putting forward and how the user interactions are evolving with time. You need to be able to trace the usage of your prompts. So when you're typically putting together a classic web application or any kind of application, you've got some kind of logging there, but you want to actually trace what's actually happened from a natural language input in terms of what the user's input, what the context it was working with to come up with its answer if you're doing a RAG-based app or whatever, and then what it produced in the end. And you need it needs to be easy to access different versions. This is kind of what I was talking about before. What was the difference between version 17 of the prompt or version 15 of the prompt with this model, with that model, etc. So these become first-class citizens as far as your version control goes. Okay, I'm just going to touch on two kind of common uses of large language models at the moment and things that you need to consider there. So assuming you've got all your kind of guardrails in place, etc., that you need to formulate that input, you're aware of context right and the implications there, then, okay, how do we start looking into some of these real applications here? So RAG's been around for ages. Everyone's probably perhaps sick to death of hearing about it, but it does have a number of limitations. So we've got limited contextual understanding. It doesn't understand your domain. Can't access complex questions requiring information from multiple sources because it's typically specific to a particular document and just the context around that particular paragraph or snippet that you took from it. Breaks documents, so breaking documents loses the importance between the relationships between parts of the documents, and you can actually address this to some extent by, once again, it's got a time cost associated with it, where you put a model first of all to go ahead and parse the document, work out what the important points are, and then you've got the other ability to kind of go through the document and work out how similar different pieces of text are, and then group similar pieces of text together, even though they don't necessarily appear in the same parts of the document. There's a couple of advanced strategies that you can do around that. But the point is you're still going to lose some fidelity there. Unfortunately, with RAG, you've typically got no visibility in terms of why particular chunks were returned, and often systems return semantically similar but contextually irrelevant chunks. So there's a whole lot of stuff around RAG in terms of things that you can do with prompts as well. So when you're doing embeddings, for example, you actually embed the question the user's going to ask, or as opposed to actually embedding that piece of text. So the idea is you're given a piece of text, you say, generate a series of questions which will go ahead and produce this type of text, and then you embed the questions as opposed to embedding the results. And then of course you can do that multiple times, and there's a number of other kind of techniques that you can kind of do to address some of these. But what becomes kind of more interesting in terms of these main themes here is this kind of concept of graph RAG for those of you who aren't using it at the moment. And so what I've pretty much just outlined before is this kind of concept here that we're looking at kind of two different layers. We've got this lexical layer, which is kind of classic in most RAG-based applications that people will be familiar with, where we've got the series, we've got a document, we've got a series of connected chunks. We've got a little bit of metadata associated with them, which is saying this is the previous chunk, this is the next chunk, so you know where it's positioned within the document and getting a little bit of idea of what's happening with that. But when you want to start getting to a high degree of reliability there and trying to get some of that context here, you need to start working on kind of a domain layer on top of the documents that you're working with. And so this is where GraphRag pretty much comes into play. And so you can see here in this particular example, I realize that text might be a little bit small, but in short, placing some sort of recognition over your model to go ahead and extract the important elements from that. So we're talking about named entity recognition or whatever else that realizes you're talking about this particular person from this particular location or whatever else, and extracting that and putting it into some sort of representation such that when you retrieve the chunk, you can go ahead and look to fetch some of this other kind of relevant information. Say, oh, okay, it's actually talking about so-and-so. Well, here's where else this particular person is mentioned in other particular documents, or whatever other things. And you've got other metadata associated with them as well that you can fit readily. So building these kind of systems, if you're interested, it's a lot of graph database technologies, Neo4j, there's Ontotext, there's a whole lot of different ones that you can look at in this particular space. But the idea is relatively simple in that regard. First of all, you want to load your document into the system, and ideally as Markdown, because large language models are particularly good with that. And at MakerX, we happen to have a product which is working in this particular space to produce high fidelity Markdown documents from scans. But the next stage is once you've loaded the document, you want this kind of concept of semantic chunking, which I alluded to before, which is basically passing another model to go over it to go ahead and work out what parts of the text relate to other parts of the text, so they can be grouped together easily, as opposed to just doing something at page breaks or paragraph breaks or every 250 characters or whatever other types of techniques that you may have there. You, of course, embed the chunks, and then, of course, you use named entity recognition, which is a different type of model. So it's not typically a large language model that you use for this, but they're small optimized models which can sit within memory, or you can use something off, say, AWS or Azure Cognitive Services, or just something off Hugging Face to be able to do this. And to basically extract those entities and then basically give you the ability to put them into your database. And you write what's referred to as your knowledge graph and store it in your graph database. So yeah, there's some advanced things around RAG there for those who aren't necessarily working in the space. There's a slightly advanced scenario which I won't go into here too much, but you've got the ability, once you've extracted this domain layer, to start inferring other things in terms of people's relationships and whatever else, which is not typically available through your standard vector database. The other very popular thing at the moment, as indicated before, is something around agents, as it were. So whether it's coding agents, agent swarms, or whatever else. And hopefully I've kind of alluded to this when I've mentioned about context rot, and a lot of these can be inferred from that and around what I've covered in guardrails, but I'll be a bit more explicit in this list here. And so things that you need to consider when you're putting together these reliable agentic systems. So first of all, we want to have a comprehensive document of the process that you're trying to achieve. It may be referred to as artificial intelligence, but it doesn't have all the context or the domain knowledge that it needs to be able to go ahead and make informed, reliable decisions about your particular industry or domain here. And so that means you need to be able to come up with a good document in terms of exactly what you want to achieve. It's not the case of the AI as being stupid or anything like that, but if you aren't able to kind of clearly articulate what you're trying to achieve, what the boundary conditions are, etc., then whatever you try and do and say, okay, the AI will just sort it out, you're going to be in a world of fun. Second thing here is, of course, you would have seen when I was talking about semantic router, etc. Do have a look at if you can actually achieve what you're wanting to do using a deterministic workflow. And what I mean by that is, as workflows have been around for a long time, maybe you, does it really need to be relying on a large language model to go ahead and try and make the decisions, or is there some kind of threshold or cutoffs or other some kind of tools that you can use to go ahead and make these decisions for you? Assuming that's out the window, because we are talking about agentic systems here, then the next thing that we need to look at is, yes, we're looking at having these things run autonomously, and as a result, you need to make, for one of your tool calls for your agents to use, it needs to be high priority and a first-class citizen, is the ability to contact a human, and needs to be able to do so easily. So the thing is the models are going to struggle, whether it's through context rot, repetition, failed retries, trying to solve the same problem over and over and over. You can't leave them completed by themselves. You always need to build an escape hatch, and a lot of it's here coming from software development background will be aware that if you don't put your app together right, then people are always going to be using workarounds. And so as a result, when you're developing an autonomous system, you need to make sure that it can call for help. The other thing here, which might not stick out immediately, but just because you're feeding natural language into the system, all user requests need to be put in to provide that kind of structure around that. And I hinted at this to some extent when we're talking about graph-based databases and doing this in RAG-based applications. The idea is that you actually want to go ahead and start looking to some kind of structure around your input. So you've got the initial user prompt here, but you might want to do some named entity recognition on top of that to go ahead and pick out the particular things that they're interested in and some other associated data with that. And so this way you can work with that data, you can query it reliably when you need to go ahead and backtrack and try and work out what's actually going wrong with your system. It also makes it easier for to be able to parse out the relevant context pieces that you're interested in passing on to your other agents, as it were, as opposed to just passing the initial text that it's got and building up the context as before. The other thing that we want, which hopefully obvious to most people working from a software space, is you want to make sure that your tool calls are secure, isolated, and run with least privilege. And so I talked about prompt injection before, how none of us are smart enough to go ahead and solve that. It's an ever-going arms race. It's just simply an intractable problem in that regard. And so as a result, you need to make sure that security is first class in terms of you've got your user data or whatever data that you're accessing partitioned appropriately with the appropriate access. And it's kind of the classic thing from back in the day when SQL injection was a big thing, still is a thing these days. And be mindful in terms of how you've actually structured this. And this kind of ties into what I talked about before about prompt injection as well. If your tool is accessing content from the internet, or maybe just from your knowledge base or whatever user-submitted data is going into your system, which is not being created by people within your organization, once again, there could be indirect prompts. So in a Word document, at the bottom of the document, there could be something in font size 1, which is in the color white, that the model is just going to treat just like any other text when it goes ahead and reads it, and as a result, will attempt to go ahead and execute that as well. So you need to be particularly mindful of what data exfiltration may look like and what attempts they're going to be to try and fetch your data. Because just as it's been a thing in the creative industry when the first advent of generative AI and starting to go through these diffusion-based models where they're starting to produce images and things like that, and just all the copyright issues and etc. associated with that, people will be poisoning text data as well. People will be making active attempts to go ahead and try and break your system. Or there could be a document from 2 years ago which has already got this in there for someone who's mindful of that, is going to be picking that up and going ahead and trying to do whatever's in that document there as well. So be particularly mindful of leaving your agents running autonomously over the data, because you're not going to be able to go ahead and address that effectively. You want to save your state often, and you need to be able to reload it easily. So just in kind of classic workflows, for some reason the agent may collapse, in which case you want to go ahead and be able to reload that previous state and start replaying it and work out what's going on there. So this needs to be a first-class consideration when you're working in these kind of environments. As indicated before, the model your agent may get trapped in a particular loop, so you need some way to detect that it's making 2 or 3 or 4 attempts at this and need to be able to stop it easily. So have your appropriate retry logic and an appropriate escape hatch there as well to say, okay, I give up. You need to also record your failures and add them to the context so the model knows what not to try again, especially if you're feeding it through to a new one, which is going to go through the same set of mistakes. The other thing is just because models seem to be getting better and better, they're also getting bigger. But the thing is, they've actually found you have more success with small specialized agents as opposed to going ahead and trying to get your main agent to pretty much do everything. And you would see this if you're using agentic coding, for example, when you're going through and having specific sub-agents to go ahead and say, well, when you're working with this particular library or this particular framework, these are the rules that I want you to follow, rather than trying to put it in and get everything right in your initial system prompt. As indicated before, you really want to minimize the impact of indirect prompt injection. This is just going to get bigger and bigger and bigger over the next few years because there's a lot of people, it's good to have a great turnout here today, but a lot of people who are already disenfranchised with AI, and there are some real applications there just to point out. So the thing is it's wrong to be completely negative, but there's also a lot of drawbacks with this kind of technology. But as a result, you're going to have people who are actively trying to thwart the system, as it were. And this is unavoidable. This is just going to be in the internet data out there. And the thing is, it's a lot of work for these providers of these large language models to go ahead and trawl through all that data effectively. And some of the things which are done there in terms of how these models are trained, a lot of content was initially from Reddit, for example, and going through there, and there's a lot of threads in Reddit, of those who've ever used Reddit here before, which are essentially full of nonsense, and have got things such as nonsense characters and whatever else, which you'll get non-deterministic model behavior if you put in one of these tokens, because they've had to go through and prod the model and remove references to these tokens. And so this is where you start getting things where it starts extracting the system prompt or it's training data or whatever else, simply because of these workarounds here. So indirect prompts are already in the training data for your next generation of large language models already. A great attempt to try and obviously remove that, but in terms of the documents or emails that you're receiving, if you've got an agent working over emails, you can imagine the implications there. As mentioned before, you want to avoid extended thinking and long-running context. You want to keep your context small. I just can't reinforce this enough. And so, yeah, that's probably the big thing around agents. And so now we're going to go down, how do you test these systems? So, concept of eval, so in terms of you want to be able to evaluate how your systems go. How do you determine that the system does what it's meant to do? Which is of course one thing. So this is kind of concept, the analogy would be something like unit tests or integration tests. If you're using one of these larger providers' models, one of the things is they do roll them over at a certain cadence. So the thing is, it's going to be very hard to access GPT 3.5 right now. And this is going to keep rolling these things forward. So if you design a system against a particular language model, behaviors do change. And so one of the things is for example, GPT 4.5, which was out for a while, got rolled back because it's too sycophantic and had a whole lot of other issues associated with it. You need to have evals to go ahead and evaluate the new models as they come out, because it is inevitable if you're relying on those. And you also need to track changes in user behavior, which I mentioned before, because just the way that we're using language models today with agentic systems is different to what it was 2 years ago. It's going to be different to 5 years, and it's going to be different, for example, when my kids are through school and university in another 10 years or whatever. So user behavior and expectations of your models are going to change. And so as such, you need to evaluate it. So first thing is you need to determine what you're testing for. You need to develop your prompts to go ahead and validate that it's actually doing what it's meant to be doing, or automate the development thereof. You can do that with large language models as well to produce some of that synthetic data. The point is hey and craft, careful human analysis of putting these things together is going to be the fastest route, or produce the highest quality results. You've got this concept of being able to use a large language model as a judge of these outputs or whatever test that you put through, so you can put it through a CI pipeline rather than having someone ticking the boxes every time. So just like we do in software, having automated tests. But once again, for this, depending on how critical your system is in terms of what you're testing for, you will want to have humans in the loop. So humans in the loop are the most important thing in terms of when you're actually testing these things. But if you need to go ahead and just from the volume or scale that you're dealing with, thousands of evals or whatever else, is not feasible to go ahead and do that on a regular basis. And instead, you need to be picky in terms of what you do it with. And of course, capture telemetry at runtime and for how your model's behaving. You can actually have a large language, have another model sitting on top and evaluating each of the current model's responses, putting that into the logs, and then basically if it's not happy with the response, you can go ahead, flag it in your system, and then have a human evaluator go back on it. So that's the happy path. The unhappy path is somewhat similar. Large language models are inherently hackable because attacks exploit their core function rather than circumvent it, or to put it in perhaps a little bit easier to understand, good or bad, whatever an LLM is given is taken for granted. It's not going to be able to distinguish between me or anyone else in this room, despite how crafty we may be in terms of our attempts in terms of get it to do what we want it to do. And as a result, yes, we end up with this interesting situation where we're actually dealing with AI safety as opposed to security of the system, because the system is doing what it's meant to do, right, as opposed to what's often encountered otherwise. And so this is kind of like a different type of eval here. We're talking about red teaming. It's where you're basically trying to work out, what does the system do when someone tries to get it to do something which is not in its core functionality. A number of ways to do that. There's tools such as PromptFoo and other tools out there which can automate your test generation. And to give you an idea, there's a concept of the OWASP top 10, so top 10 common exploits for large language models, etc. And so you're best to kind of use a tool to go ahead and do this. And to give you an idea, using these tools, you can generate the kind of number of red teaming prompts that you're going to be coming up with could be anywhere between maybe a couple of hundred, couple of thousand, 50,000 to 100,000 or more prompts. And so when you're doing this kind of red teaming, if you're very serious about it, you have a team dedicated to it, or maybe getting a third party to help you out with. But if you're doing something smaller scale, maybe just something with PromptFoo or the like, choosing which ones are the most important to you and getting it to generate that. But you can't necessarily get this on every build or necessarily at runtime. As you can imagine, generating thousands of adversarial prompts simply takes time, and then of course to run them through the system simply takes time. So this isn't something which just takes 5 minutes in CI or whatever else. This is something that you need to plan along as you're looking to develop and deploy your app. And so yes, red team is expensive. It'll likely have a separate cadence to your standard CI pipeline. So you might have a couple of evals in your standard CI pipeline, whereas red team is something that you say, okay, X many weeks before we go live, or ideally actually from the start as soon as you've got some basic parts in there, but not all of us have the luxury of having that support. But yes, this is definitely a high priority when you're trying to get that reliability. And finally, I mentioned observability was absent from that architecture that I showed at the end there. And so what does that look like? So from observability, once again, make sure you understand PI requirements. I know it might sound funny, but people do anthropomorphize models, and there's nothing necessarily wrong with that, depending, but they may share more than they want to. So given an example, your general chatbot sitting on, for example, a website or whatever else, people might start pouring out their innermost secrets, or thinking, yes, this is a living being on the end of here, or an intelligent entity or whatever else, and start sharing things like their home address, other kind of things about their life or whatever you need to be aware of. This does happen. And so as a result, you need to be mindful of what you need to mask. So most systems will need to have some sort of requirements here in terms of what's putting through. But despite that, you want to pretty much log everything. So you're going to have some sort of masking on top of this to get an idea of how your system is performing. Of course, you want to attach your system prompts. And as you can guess, with prompt versioning, we want to know which version of the system prompt we're using against that. And of course, use the evals to measure your responses. And ideally, every response and flag those that fail your evals. So this is part of your observability platform. You have either a second pass or a second model, or passing over every bit of input which is passing into your system, evaluating that against your core set of evals, anything which falls below your threshold, so say below 80% or whatever you choose, whatever industry you're in, might be higher or lower, then basically flagging that for human evaluation to follow up on. And so finally, we end up with this architecture here. So we've got a bit of observability. The topics I've touched on today have been the concept of semantic routing that appears in a myriad of different forms depending on which platform that you're using, or if you're building everything from the ground up. We've got the concept of guardrails, which we've got going both before the model, and we do our best effort before the model, but we're not going to catch everything, so we have these after the model. And this is a trade-off of time and complexity and a number of decisions to make here. But it's not a case of just simply daisy chaining large language models. If you want to take this seriously, then you start looking into other types of models which are specialized for these particular tasks, which are often a lot smaller. You can often fit these in memory, depending on which ones that you're working with. But basically, the point is it's not going to require a call which may take 2 or 3 seconds to respond from Anthropic, for example. With these kind of things, you can get responses in milliseconds, depending on which one that you're using. Prompt management is very, very important. So it's not just getting checked in with your source code, but you actually want the versions. You want a system which is able to go ahead and manage these separately and then track these and attach them appropriately. Because our usage of AI is going to change over time. The models are changing over time. Covered a little bit on RAG and agents. If you're just getting started in this thing, one of the things that you might want to look at, semantic chunking is a good start, and there's some advanced categories in that. And then if you're really starting to get serious about it and saying, okay, we really want to explore what's going on within our organisation or in this particular domain and make sure that we're getting the right kind of results, you start looking down some of these advanced type scenarios with graph RAG. Observability has kind of got your two levels, so you've got the basic infrastructure or standard kind of web request observability, but then you've got the natural language level observability that you want to integrate into your system. And of course, just like unit tests and integration tests, you've kind of got the two types of things. So, from a DevSecOps perspective, you've got your evals, which are going in and evaluating essentially your unit tests or your kind of core functionality or integration tests, as it were, when you're dealing with a multi-step system. And then, of course, you've got from a cybersecurity, or the equivalent of cybersecurity, although it's more a safety thing, is your concept of red teaming here in terms of something that's just got a slightly different cadence. Unfortunately, you can't push it through every pipeline to go ahead and test 50,000 different prompts. Depending on the system you're working in, of course, some will go through that particular process. And yeah, that's basically it. So my details are there. I've got LinkedIn, and I do work at MakerX, so do feel free to reach out to me. My name is Jack Watts, and I think might have just hit time.
Right on time. Thanks, Jack.